Piper Physics Patrol!
That's right, it's the Piper Physics Patrol. Today we're talking about Bernoulli.
The Bernoulli principle is back. Hey, where was this until we did it? All right.
It's coming back to us already. So I take this piece of paper here, and what can we say about this piece of paper, Andy?
Well, right now you've got air pressure on this side, you've got air pressure on this side, and it's not moving because the forces cancel.
Forces are the same in there. So now I'm going to do a little trick here. You've probably seen this before. You ready? Watch carefully. Whoa! What happened?
It went up.
It went up. So what does that say about the forces on the piece of paper?
Well, I guess, let's see here. The pressure from below must be greater than the pressure above because he blows and the speed goes up.
When the speed goes up, the pressure goes down.
Right.
And that's Bernoulli's principle.
Yeah.
But no, this is really not, we're not really showing this in a big way. We like to show things in a big way.
We need more wind and we need a bigger sheet of paper.
I got wind here.
I've got a long sheet of paper.
A little bit more. So let's try this out here.
Ready to go. I'm ready to go.
So Bernoulli's principle, speed goes up,
pressure goes down.
let's see what happens here.
Alright, so what's going on there? The velocity is going fast, speed goes up,
Pressure goes down,
and it gets sucked into the flow and then blown all the way
and it
out.
moves along with it. That's exactly right.
So we have another thing to show you here. It's very similar to a perfume bottle. An atomizer, you have a velocity flow going over the top, reduces the pressure, and it sucks the perfume into the flow.
Exactly.
Okay, something like that?
I'll be the bag.
Okay, I'll be the perfume.
Okay, so again, when the speed goes up, the pressure goes down, so it's going to reduce the pressure on this. And we got a little straw here, and so we've got a little green liquid just so you can see it. And so hopefully you'll see the thing. It's going to pull it up.
It's going to rise up a little bit.
A little ways up the straw, right?
Yeah.
Here we go.
So it got sucked up the straw and then blown right around. You see that? Beach ball. Here it is.
All right, beach ball. So one more thing. There's lots of different things with Bernoulli's principle. Flying an airplane actually has something to do with that.
Also, the beauties of baseball.
Baseball. Hey, it's almost baseball. April's coming up.
So here's
Sandy, Koufax, all this stuff.
Okay, here's ball without spin, right? Pretty boring. I'll just throw it right at 10. Boring. What else can happen?
Well, if we put a little bottom spin on this ball, watch the trajectory of the ball now.
It rises.
So instead of going down, it actually had a little curve up. Did you see that? Try it again. Watch this face see.
All right.
Oh yeah, you can see that? Andy's better at it than I am.
You can also throw a curveball.
See what's going on there? Okay, so here's the idea. The ball is spinning,
And the wind is coming this way. And on this side, the wind actually increases. Speed goes up.
pressure goes down.
That's right. And on this side, the speed actually decreases and the pressure is higher. So it actually curves this way.
And that's the basic. And you gotta have, for a baseball, the idea is that the seams are going to help to drag along the air as it goes along.
Now we also want to show you one more thing. You can use that principle to trap this thing and make it not fall down like it normally would.
Now this is very similar actually to a technique that's used in biology and physics right now. It's called an optical tweezer. And what they do
Speed goes up,
pressure goes down. Just to be sure. Yeah, okay, just checking that out. So the idea with the optical tweezers is that you take a DNA molecule, a single strand of DNA, and you attach a little bead onto the end of the thing.
We've made it bigger so you can see.
Here's the bead, okay? Then you put a strong light field on this thing, and the bead is what's called a high field seeker. And the same thing like this, it has a force that brings it into the high field. And so then they can manipulate a single strand.